Simplified form of a square root. A radical expression for a square root is simplified when its radicand has no factor other than 1 that is a perfect square. To factor a square root, we can use the product rule in reverse. That is, the square root of AB is equal to the square root of A times the square root of B. This property is especially useful when a radicand contains a perfect square as a factor. Let's take a look by factoring this first example. 18 can be broken down going in the reverse direction for the product rule of square root of 9 times square root of 2, since 9 times 2 is 18. The square root of 9 is a perfect square, which is 3, times the square root of 2, which cannot be simplified. It is in its simplest form. It is customary to place the radical sign as the last factor to avoid any uncertainty as to what is under the radical sign. And here we've simplified this radical. In this next example, to simplify here, since x to the fourth is x squared to the second power, we'll break it down into the following factors and then simplify each of these. The square root of something squared is that quantity. We still have our opposite of this result. And since this cannot be simplified, the only factor is 1 in itself, we'll leave the radical square root of y for that term. Our final answer then, negative x squared times the square root of y. We're making an assumption that no radicands were formed by squaring negative quantities, and because of this assumption, we do not need to use absolute value symbols when simplifying. One more example here, the square root of 80a squared b. If we use that reverse on our product rule, we can break this down into the square root of 80. And if we do our prime factorization of 80, which is 2 times 40, 40 is 2 times 20, 20 is 2 times 10, and 10 is 2 times 5, will help us find our squares in that number times the square root of a squared times the square root of b. In a square root, we're looking for a number times itself. Here we have a pair of 2's and another pair of 2's. We could rewrite these again applying the product rule of 2 times 2 times the square root of 2 times 2 times the square root of 5, and of course our variables, and simplify from there. We could have directly taken our shortcut as well, but just to illustrate, the square root of a number times itself is that number. Same thing here. The square root of 2 squared is 2. Square root of 5 we can't simplify, but square root of a squared will result in a, and square root of b, since there's only one b, it cannot be simplified. We'll combine those two radicands using our product rule as follows. And to simplify this in its final form, 2 times 2, we could have our final answer as 4a times the radical 5b. If you recognized a perfect square within 80, a second method could be breaking down 80 into the square root of 16 times the square root of 5. 16 times 5 equals 80, and simplifying it from there. But just to illustrate that we do, in fact, get the same answer, I'll continue on. Square root of 16 is 4. I cannot simplify square root of 5, but square root of a squared is an a. neither can we simplify b. And to clean that up, we'll put those back together with the product rule and have our answer as we previously found by using prime factorization as a method. Either one is certainly acceptable. Sometimes you see that perfect square, and other times you do need to do a prime factorization to pull out, to simplify that radical.